$10, I think.
In Walmart?
Yeah, Walmart. Yep.
I think that would be like that one.
It's very useful. It's watertight, so it's not like any water's going to be in there. Oh man, look at that. Shouldn't be. No, we didn't. We weren't able to fill the third layer up 100%.
Okay, so it's okay.
Yeah, should be fine. Jacobsville, you can see the mud class in it. Yeah, there's other class in it too. Little Presque Isle, this tiny little island just north of Marquette, is perhaps one of the most interesting things to me out there in the field. I love this little island, and as a geologist, I find it extremely fascinating. The island isn't all that big. Me and others have been working on it for years. Some people have been trying to get paleomagnetic data from them. I have been mapping the island slowly, bit by bit. There is a lot of geology here. The geology of Little Presque Isle is all Precambrian, except for the modern Quaternary sand deposits, which cover the east and southeast side of the island. So come with me, my friends, colleagues, and wife on this journey to see the processes of geologic mapping. Well, some of them. Again, they're all not applicable here. As well as my final journey on making a complete map to the best that I can with the data available. Anyway, I hope you guys enjoy this. Okay, so it's August 21st, 2021. We are at Little Presque Isle. We are going to attempt to walk to the island to finish some geology work that we noticed last time we were here a couple of years ago. And hopefully this will be the last time. I will take you guys on the journey to show you the island. It's a lot of geology in this little island that's out here. Most of the footage will be from today. If not, I'll put it on the screen if it's from a different date, because we've been here before. It's totally doable today. That they're going. Remember when that was up there? We are on Little Presque Isle. When you cross into the lake and you come on the very bottom southern tip. I was going to record there, but we couldn't. It was too windy. What you see there is mostly conglomerate of the Jackson Creek Formation of the Jacobsville group. And today I'm going to take you on a tour of the geology of this island. It's a lot bigger than it looks when you're sitting on the shore, but you can see this is where you come in. We're about right here. So we're right near the contact where the Jackson Creek gives way to the Orienta Formation. I believe that's what it does there. I think I got that. Yes, it is. And we're going to come up this way. I'm going to show you the main units. Now, you see this little green part here? All right, there's a little green part on the map. That's that black and white looking thing over there. That's actually a dike. There's several dikes that cross-cut the main body, which is an Archean gneissic granite type suite. We'll talk more about that later. And they vary in age. We know one is Penokean. Those are some lampifiers. Hopefully we can have time to see them. Those have been dated. There are some Keweenaw dikes here, which are black. And then there's these. And we're not sure how old they are. But they're probably Archean as well. Maybe early Proterozoic. The sand is Quaternary from the glaciers and the post-glacial winds, but this is all Jacobsville here. And you can see this is not conglomeratic, unlike the stuff at the very southern tip. These are erratics, not dumped by the glaciers directly. Humans didn't dump this. This would have come in on the waves in the winter. You can see it goes significantly out into the lake. If someone was going to engineer dump this, they wouldn't have taken it that far into the lake. Right now, I'm just looking for a dike that Elisa thought she saw when she was here last. Now, I thought the dike would be right here. This is not it. We can talk a little bit about it in a minute. As you can see, there's some dikelets within the granitic rock. Okay, we have come up from the Jacobs Hill, which is down there. It's not too far. We are looking for that dike still, but before we continue looking for it, because we haven't found it, I'm going to talk about this real quick. This island is here for a reason. I don't mean in the mythical, metaphysical sense reason, I mean physical reason. The geology of this island is why this is here. You do see islands like this further south towards Marquette. This is the only one that's right here, and it's isolated. Why is that? Well, this is the Archean basement rock right here. It's either a granitic rock or gneiss. It's not a granite because it's more tonalite granodiorite. But this part right here is extremely resilient. This island probably forms the outline of a single pluton. And there's evidence for that. I don't know if I'm going to be able to take you to the edge of this pluton. It's part of what's called the Campo Creek gneiss. Neo-Archean igneous intrusions that form a large part of the basement, the vast majority of the basement in this area. Now, unlike further south in northeastern Wisconsin with the Penokean Orogeny, no one has bothered to try to separate out these plutons. That's something a graduate student can work on sometime in the future. So on the west side of the island, it's across. And what you can see down here is you see these black stringers. You can see them in the camera. And I've never been down there, but it could be weathering, but I don't think it is because there is a dike right there where they're standing. We've actually recorded that before, but these could be dikes as well, or amphibolitic foliations within the edge of this pluton. There's no way to tell without actually looking. So we're going to go back up and see if we can find the mystery dike up there. We're getting near the highest point of the island. It's actually up there. I'm not seeing anything that looks like a dike. Here's some more dikelets. This is what we call float. It's just a generic term for close to in-place rocks, but not really, that have been removed from their source area, carried a small distance by the weathering process, whichever that may be. If you look over here, we're still on the Campo Creek. The wind has died down. You can see it. And you see a dike right there that terminates right at the end of the gneiss. You can see it, it's right there. And it comes up here, and I gotta check and make sure. This might have been, but they weren't following that. I think I have this one. Pretty sure I do. Let's see if I can see it a little better. There you go. Oh yeah, we've definitely mapped this one. I know this one. You can kind of see it's offset. All right. We found the dike. It's very obscured and covered. GPS 46.63932 minus 87.45931. I am not standing on the dike. Sarah is. This thing was really hard to see. If you look this way, down here, do you see the dike? Yeah, I didn't see it either. And if you were to turn around, yeah, right there. You see it down there? Yeah, I didn't either. But it comes from about there, and then it comes down on the trail to about where I am. I am standing on it now. This is it right here. the foliations or the fractures within the dike, fractures, do not quite follow the trend of the valley. And it does appear to just go down to the lake. Now, I looked at the rock. It exists mostly as float. That's why it was so hard to find. Walking on it, and a lot of times that's as good of an exposure as you get. We're walking in the woods, we see the hills of granitic rock, okay, and all of a sudden I see this black looking rock loose on the ground. I pick it up. Okay, this is clearly not a granitic rock. Well, where did it come from? It's not in place. Well, it was a piece of float and probably is resting right where it was originally from, because we were near the top of the high point and rocks don't roll uphill. You know, someone could have thrown it there, but then I start looking around and I start seeing 2, 3, 10, 20, 50 of these things. Plus there's a fallen tree back there which has a nice chunk in it. So I start taking GPSs of where I can see it is, because it's hard to see the exact trend because it's so covered. I did find one in-place outcrop and I did log it. And it's near the edge. It's right near the edge of where the granite meets the granite. So basically, if Elisa hadn't stumbled upon this, and this is the first time we've been up on this area, I just made the bad assumption that there wouldn't be any dikes up here. I know most people studying the dikes on this island are interested in the Keweenaw dikes, the black basaltic dikes. So I just wanted to show you how tough it could be to actually do this in the field, and how you can walk right over stuff and not see it. Now if Elisa hadn't mentioned that she saw a dike here, and if we came up this way, quite honestly, I would have been looking for it. I would have just walked right over it probably. I mean, doesn't mean I would have. I might have just tripped and been like, oh yeah, this doesn't match that. And as you look down here, you can see this rock in the trail has a completely different texture. You can't really go off the color because it's weathering. It's a completely different texture than this stuff. The granitic stuff's going to form the high ground because granitic rocks weather more slowly than mafic rocks. So it makes sense that the dike is in the low area. Another thing that kind of would have tripped me up if I wasn't looking for an actual dike is you can see the mafic stuff here, but here you see lighter colored rock. Feldspar rich, because there is, this dike has a xenocrest of the Archean compu gneiss in it, and a couple veins of more felsic rock. But I'm walking on the dike right now. Dike is down there, and now it's gone. So we're gonna go to the north end of the island, come down the east, turn around, and go back. Look at that quartz. I think that's a good idea. Snorkeling here. Do you see Granite Island in the distance there is? You look at the granitic rocks here as we go this way. Now, how can you tell if a rock has primary magmatic foliations in it? You know, as the rock cooled, it was more plastic and formed, you know, lineations, or if it is actually metamorphic. Well, that can be really hard to tell. One way to do it is to look actually at the orientation of the foliations. I'm looking for some here. Might be some up here. If they appear more random, and they actually do up here, in orientation, you have more than likely primary foliation from the magma body as it cooled. If it's more aligned and linear, well, as rocks become metamorphosed, those foliations are going to become subparallel to parallel. And that's a key indication that they have undergone metamorphism. I tried to find the Keweenaw basaltic dike that shows the columnar jointing. I couldn't find it. I gave up. I didn't have any water with me. But I do have pictures and video of it from a couple of years ago. And what you can see is you see how it's so strikingly different from the surrounding Compo Creek gneiss. It's black And the fractures or columnar joints are something you do not see in the gneiss at all. So we know this was a dike that came up perpendicular to the columnar jointing. I came up here and I wanted to show you one other thing. It's actually right down here. It's the lamprifiers. There's two cross-cutting dikes of highly ultramafic rock lamprifier that are offset by a fault. I actually, to my embarrassment, got turned around down there. And I think I actually walked over it, not realizing what I was doing at the time because I was focused on getting back. The dikes are limited in scope. They're easily traceable. They don't propagate throughout the island. They're in this one eastern spot. Those have been dated. Those are dated to the Penokean Orogeny. So we have this Archean basement rock, this gneiss, which intruded 2.7 billion with a B years ago, plus or minus. Then we have these really mafic, ultramafic, sort of phaneritic dikes cross-cutting into it. They're greenish in color. Those have not been dated, probably Neo-Archean, like the gneiss itself, or Paleoproterozoic, circa 2.5 billion years ago, which would make sense because 2.5 billion years ago, with a B, in this area, North American continent did successfully rift. And that's how we got the Huronian supergroup to the north, across the border in Canada. The other part, we argue about what it was. It could either been the Wyoming craton or the Cup Val. I'll correct it if it's not craton in South Africa, or both. So that went on its merry way, so it would make sense that those dikes are around that age, because the base of the Huronian is volcanic, the rest is pretty much sedimentary, well, metasedimentary. So then, fast forward, and those Keweenaw basaltic dikes intrude this as a mid-continent rift formed, trying to rip North America apart again, this time failing. Now, between the successful rift and the failed rift, we had that Penokean Orogeny, and I've taken you to that before in Wisconsin. The Penokean, after North America successfully rifted and those cratons, the Cup Val, Wyoming, whatever, went on their merry way, at about 1.85 billion years ago, the Penokean terrain accreted, which consists of the Pembine, Wausau, and a couple of others, and that's when those lamprifiers were deposited. From there, fast forward, to 1.1 billion years ago. Sorry, I'm a bit winded and off my game a little. And that's when you get the Keweenaw basaltic dikes intruding because of the mid-continent rift. That failed. Subsidence started. And the Jacobsville group of sandstones and conglomerates became deposited. And when the Jacobsville was getting deposited, this island probably pretty much looked like this, except what was coming in wasn't a sea. There was no water here. It was terrestrial. The Jacobsville's fluvial, and a lot of it was probably sourced from right here. But the hill would have been here. The Jacobsville would eventually cover it. Then the Phanerozoic could come by after some erosion took place. And those seas would come in, deposit, and subsequently become eroded. Then at the beginning of the Quaternary, about 2 million, with an M, years ago, to, 10,000 years ago, probably 11,000 here, somewhere around there. The glaciers came through and carved all this out, polished it up, made it look nice and pretty, exposed some things for us, covered up some other things, hid them from us. Anyway, I think that's it. But if you have any questions or comments, please leave them below, and I hope you learned something. But anyway, let's get going and take you on this little tour. Oh, you see the butterfly?
Gliding. Oh.
Hey frog, what you doing? You could have said that with the recording. Hey there. We know where to go. Got some tadpoles over here. You can see them a little bit. There's somebody swimming right there. There's a couple of them. Yeah. Oh, there goes one. Doing okay, Sarah?
Yeah.
Okay.